Good evening, good morning, and good afternoon to all of those watching around the world. My name is Hugh Bradlow. I'm president of the Australian Academy of Technological Sciences and Engineering, and I'm chair of the CAETS Communication Committee. And I'm accompanied today by Lucas Nolders from the Netherlands, who is the deputy chair of the CAETS Communications Committee. Tonight, it is my pleasure to introduce the first CAETS Communication Prizes, the inaugural awards for those prizes. The CAETS Communications Prizes were set up to address the need for engineers and technological scientists to communicate their work to a general audience in a way that was engaging and encouraging to members of the public, that encouraged them and their children to do engineering, and also enable them to recognize the importance of the technological sciences and engineering in our society. The awards recognize two types. We have two types of awards. The first is so-called engineering success stories, where we give an award for an invention or development that has made a significant difference to mankind already. And the second is high potential innovations that have not yet had the chance to prove themselves, but are submitted by younger researchers and are believed to be important developments for the future. The aim of the prizes was to present the development in a short, engaging video that people could watch and understand and be encouraged by. So we set up a judging panel from the CAETS board member countries, plus myself and Lucas. And that judging panel has chosen tonight's winners. I do want to emphasize that we were not allowed to judge entries from our own country. So the judging panel was impartial in that regard. I will start off tonight by handing over to Lucas to make the award for the engineering success story. Lucas.
Thank you very much, Hugh. Ladies and gentlemen, it's a pleasure to address all the participants of the CAETS conference and to announce the winner of the CAETS Communication Prize in the category Engineering Success Stories. We have received very impressive nominations and contributions from Argentina, Australia, China, the Netherlands, Spain, United Kingdom, and Uruguay. And the judging panel has enjoyed viewing the videos, discussing them, and rating them for the various say, success criteria. And I'm pleased to announce that the winning contribution comes from China. And the winner is Professor Jin Cheng from Tsinghua University in Beijing and Capital Biotechnology, with a contribution entitled Fully Integrated Chip Laboratory System for SARS-CoV-2 Nucleic Acid Detection. Before we are going to view the video, all of us, I'm going to read out the official judgment. Professor Cheng's engineering success story is a very inspiring and clear example of public-private partnering, knowledge transfer from academia to a company, and successful deployment to tackle a major societal problem. The language used in the video is simple and easy to comprehend for a non-technical audience. It clearly shows the value of engineering in the face of an international crisis. The dramatic tone and style make it even more engaging for viewers and inspiring for young people and students, the primary target group in our CAETS Communication Prize competition. The video clearly describes a problem, that is the need for rapid testing related to the COVID pandemic, its importance and its urgency. The speaker points out that the new automated tool helps to minimize human intervention in the test procedure and explains the problems faced by this type of technology and more traditional solutions. Next, we see a clear presentation and explanation of the COVID-19 test apparatus, including a detailed demonstration and applications in various contexts and a mobile laboratory. The benefits of the solution become clear to the viewer. The system developed for COVID testing is in operation at multiple places across China, also in the mobile lab that travels from site to site. More than 10,000 tests had already been conducted by the time the video was produced. The citing of patents, academic publications, and footage of products in action make the success story more credible and verifiable. Therefore, the judging panel was unanimous in its decision to award the CAETS 2021 Communications Prize for Engineering Success Stories to Professor Jing Cheng. I congratulate you with winning this prize, and I now invite all participants to view the winning video.
Since the winter of 2019, the COVID-19 pandemic has swept the world with high social and economic cost. A succession of clusters of cases also emerged in China, bringing huge challenges to epidemic prevention and control. In response, the Chinese government calls for measures to enhance nucleic acid testing capability and carry out nucleic acid testing for the whole population of key areas. However, conventional nucleic acid testing technologies suffer from requirement in operation space, technicians, and supplies which greatly hinder the enhancement of nucleic acid testing capability. With nearly 20 years of experiences in pathogen detection, Professor Cheng Jing, academician of the Chinese Academy of Engineering, Tsinghua University professor with his team at Capital Bio, has responded to the call of the state by ramping up their R&D efforts to launch the fully integrated lab-on-a-chip system for rapid nucleic acid detection of SARS-CoV-2. The system is comprised of the fully integrated SARS-CoV-2 nucleic acid detection kit, disk chip, and the fully automated nucleic acid analyzer. With the integrated microfluidic chip-based nucleic acid extraction and purification technology and the nested isothermal amplification technology, this system can rapidly and accurately perform a fully automated, fully sealed sample in and out testing procedure for SARS-CoV-2 samples. Based on the advanced lab-on-a-chip design concept, it simplifies the whole testing procedure. The only manual operation is to add the sample preservation fluid into the chip and put it in the automatic analyzer, which takes less than 1 minute. The whole biological processes, including nucleic acid extraction, purification, amplification, fluorescent testing, and interpretation of the test result, etc., are all integrated into self-contained and internally partitioned microfluidic chip, which eliminates the need for separated high biosafety level laboratory. There is no need for manual intervention, which minimizes the risks of operator infection and cross-contamination among samples. Each chip is divided into Zone A and Zone B to test 2 samples at once. The whole testing process takes less than 45 minutes and can detect positive samples of the SARS-CoV-2 in the shortest time of 35 minutes. The lab-on-a-chip technology adopts the proprietary nested isothermal amplification technology and achieves testing sensitivity as low as 150 copies per milliliters, which effectively reduces false negative results in detecting low virus loading samples. It has the highest sensitivity among commercial products approved for the Chinese market up to now. The automatic analyzer is built with a flexible product platform which can be used as a standalone machine or operate in parallel with up to 60 machines, which effectively reduces the requirement for operation space, labor, and materials. The system is compatible with a variety of biochips and can be further modified in the future based on the sample types. The complete system has been granted 6 patents for invention, 6 patents for utility models, and 1 appearance design patent, and obtained National Medical Products Administration Certificate and CEIVD approval. This work has been published in Clinical Chemistry, a leading international journal in the field of laboratory medicine. In addition, Professor Cheng Jing has led a multidisciplinary team at Tsinghua University to rapidly develop the Light Cavalry Mobile Lab for SARS-CoV-2 nucleic acid detection, which is equipped with this technology and the pharyngeal swab automatic sampling robot. It serves as a rapid, mobile, and safe testing platform for the epidemic prevention and control, and significantly enhances the capacity of emergency response to new outbreaks of infectious diseases. It can be widely applied in hospitals, disease control institutions, airports, railway stations, schools, customs, military, import and export ports, and some other emergency scenarios. Currently, it has been deployed in Guangzhou, Zhuhai, Qingdao, Songpan County of Aba region in Sichuan province, Jiuzhaigou Valley, and many other places in China, and completed nearly 10,000 nucleic acid tests in total. This mobile app will soon be put into use in Indonesia, Italy, the United Arab Emirates, and other countries. The fully integrated chip laboratory system and the mobile app for SARS-CoV-2 nucleic acid detection have become important tools for the coordinated epidemic prevention and control works across China. The epidemic containment efforts should not be bogged down by national borders. Professor Cheng Jing and his team will continue to support the global efforts to fight the epidemic with the power of Chinese chip.
And once again, congratulations, Professor Chung, a remarkable development, and we're really pleased to be able to show it at the CAETS Convocation 2021. I'll now switch to the High Potential Innovation Prize, which, as I mentioned, is intended to show an engineering breakthrough that still has not had a chance to prove itself fully, but will make a big difference in the future. It is open to young researchers who've produced a breakthrough and which shows promise. This year, the inaugural High Potential Innovation Prize goes to Mr. Cas Vermeer of the Netherlands, whose video was submitted by the Netherlands Academy of Technology and Innovation. Mr. Vermeer's video describes the problem of predicting crop yields early so distributors can forecast the availability of produce, thereby avoiding considerable wastage. Mr. Vermeer's video describes how drones can be used to visually survey crops and automatically detect their state of growth and the advancement of their growth. Whereas previously crop yield could only be accurately predicted a day in advance, Mr. Vermeer's system allows an accurate prediction up to 2 weeks prior to picking. Mr. Vermeer's system is already actually in use, and within 1 year of it being developed, is being used by 40% of broccoli growers in the Netherlands and is now being expanded to other countries. I congratulate Mr. Vermeer on his outstanding achievement and the video story describing it. Can you please play Mr. Vermeer's video?
Jaarlijks in Europa wordt er voor ongeveer 17 miljard euro aan verse groenten en fruit verspild, puur tussen de boer en de supermarkt. Dus nog voordat wij als consument dingen gaan weggooien. Vroeger had je eigenlijk heel veel boeren met eigenlijk hele kleine veldjes. Dus die boer die liep een rondje, die keek in zijn eigen veld en dan wist hij best wel goed hoeveel product hij beschikbaar zou hebben. Nu zijn die boeren veel groter geworden, hebben ze soms wel 100 voetbalvelden bij elkaar, om het zo maar te zeggen. En dat maakt het voor ze veel lastiger om in te schatten hoeveel product ze kunnen produceren. En dat is ook waar wij als Van Boven op inspelen. Van Boven biedt oogstvoorspellingen voor verse vollegronds groenten. Op dit moment is het zo dat telers eigenlijk pas een dag of 2 van tevoren weten hoeveel product ze kunnen gaan oogsten. En met onze oplossing wordt dat 2 weken. Specifiek voor broccoli maken we gebruik van dronefoto's. Die maken we eigenlijk van zo'n veld zoals hier. En verdeeld over het hele veld maken we dan foto's en dan gaan we eigenlijk op zoek naar de kleine broccoli's die daar al aan het groeien zijn. En dan bepalen we daar de maat van in die foto's. Dat gaat helemaal automatisch en daardoor weten we dan hoe de groei ervoor staat en of er al geoogst kan worden. En op basis daarvan doen we onze voorspelling. We zijn afgelopen jaar gelanceerd met ons eerste product in de broccoli, het eerste gewas waar we live mee zijn. Ongeveer 40% van het Nederlandse broccoli-areaal is nu klant van Boven, dus daar zijn we heel trots op. En ook hebben we net eerste pilots gedaan in Spanje, met als doel om eind van dit jaar in Spanje te lanceren. Ook in broccoli, maar langzaam ook in steeds meer andere gewassen.
Thank you. And once again, congratulations to Mr. Vermeer and the Netherlands Academy of Technology and Innovation. Well, ladies and gentlemen, that is the end of the inaugural CAETS Communication Prizes Awards. We would like to encourage all academies to submit videos for next year's awards. We'd like this to become an annual tradition at CAETS. We will be publicizing the winning videos around the world, hopefully, because they are excellent examples of the importance of technology and engineering to the improvement of our world. I should just add in closing that all the entries we received were of extremely high standard. And as Lucas said, the judging was a pleasure, but extremely difficult. And it was really difficult to pick a winner, but we had in the end 2 outstanding winners. And we look forward to future years where we will see equally outstanding videos. So with that, I would like to draw this session to a close. I'd like to thank the judges, and I'd particularly like to thank Lucas Noldus for the energy and innovation he has displayed in putting together these prizes with myself. So thank you all and good night.